Alright, in this video we're going to be talking about the basics of hypothesis testing. This is really where the rubber meets the road in statistics, and this is sort of why we do statistics, because we want to take our statistics, we want to make inferences from it, but we want to do it in the right way. And we want to make it, we want to test certain claims. And we do that by, we assuming that something is true, and then we take a sample and we get some statistics, and then we evaluate how likely are those statistics that we would get given that our assumption was true. So this is a very important process we do, and we're going to go over some of the basics in this video. So hypothesis testing, of course, a hypothesis is really a conjecture or a guess. And there are two types of hypotheses we'll be working with, a null hypothesis and an alternative hypothesis. The null hypothesis is any hypothesis that contains a statement of equality. So these are going to be mathematical statements involving either an equal sign, a less than or equal sign, or a greater than or equal sign. Okay, something like the mean is at least 5 or something like that, or a proportion is equal to 65%, something like that. And then the alternative hypothesis is just the complement or the opposite of the null hypothesis, and so it's going to contain an inequality, like not equals, strictly less than, strictly greater than. And so, for example, we note that HA. So, for example, if the null hypothesis says mu equals 5, the alternative hypothesis would be mu does not equal 5. If the null hypothesis is P is less than or equal to 0.6, the alternative hypothesis would be P is strictly greater than 0.6. If the null hypothesis says sigma is greater than or equal to 7, then the alternative hypothesis says mu that sigma is strictly less than 7. So exactly one of these hypotheses are going to be true. And as you can see, we denote the null hypothesis H0, the 0 kind of goes with the null, and HA for the alternative hypothesis. So in this game, the whole entire game of hypothesis testing, the way you play this game is you assume the null hypothesis is true, and then you do your work, and then you either reject or you don't reject the null hypothesis. That null hypothesis may be the claim that you're testing, or it might not be. We'll get to that in a minute. But if you do reject the null hypothesis and conclude, oh, it's not true, then the alternative hypothesis must be true. So if you do something, if you reject the null hypothesis, you're supporting the alternative hypothesis. If you don't reject the null hypothesis, that's basically you're saying you can't make any conclusions. You're not necessarily saying that the null hypothesis is true. You just say there's not enough evidence to reject it. So, of course, there are some errors you can make in this. There are two types of errors in this game. You could, if H0 is true, the null hypothesis is true, and you reject it, that's called a type 1 error. Okay, that's one of the more active errors because you're actually doing something. If the null hypothesis is false and you don't reject it, that's called a type 2 error, and that's a more passive error. And you can, of course, sort of think of this as if you go back to, if you're like a part of a jury in a trial, a type 1 error is, of course, type 1 error is when you convict a defendant that is innocent. Okay, because you start out by assuming the defendant is not guilty, and then you convict them. You reject that premise of not guilty, and you replace it with guilty. So that would be a type 1 error. A type 2 error would be acquitting saying a guilty person is not guilty. Okay, that would be more of a passive thing. So the way that there's always some error involved, and we have this thing called a level of significance, which is the maximum probability of a type 1 error. Okay, so you're going to be evaluating claims with a certain level of significance, like if it's 10%, then you're saying, well, there's a 10% chance that I'm rejecting the null hypothesis when it's true. That's what level of significance means. Okay, and so when you test a claim, the claim may or may not be the null hypothesis. Depends if there's equality in the statement. But when all is said and done, you're going to be coming up with one of these four conclusions, right? If the claim is the null hypothesis and you don't reject it, you say there's not enough evidence to reject the claim. If the claim is the null hypothesis and you reject it, you say there's enough evidence to reject the claim. If the claim is the alternative hypothesis, you don't reject it, you just say there's not enough evidence to support the claim. You can't really say that when you don't reject something, you're not making a conclusion either way. So you say there's not enough evidence to reject to support this claim. But if the claim is the alternative hypothesis and you're rejecting the null hypothesis, so when you reject the null hypothesis, you're supporting the alternative hypothesis. So in that case, you would say there's enough evidence to support the claim. Now, one thing about where statistics are going to fall into this, we studied sample means distributions, and we'll know in advance, what type, if the sample means are normally distributed or if they have a t-distribution or something like that. And then what we do is we are going to assume, when we assume the null hypothesis is true, we're going to assume, so like if we assume that in this case, if mu is greater than or equal to some number k, then the alternative would be mu is less than k. And if we assume that if we assume this is true, that mu is greater than or equal to k, then we know that the most unlikely means would be less than k. So that means the sample means would be over here. So what we're going to do is we're going to set up these what we call rejection regions. And that's basically that this area is equal to alpha, which is the level of significance. So we can see here that, let's say, if level of significance is 10%, this area is 10%. So there's a 10% chance that that means would fall into here. Well, we would say that, so if we take a sample, we look at the mean, and it falls into this region, okay, we reject it. We say, okay, this is just way too unlikely, we reject it. Okay, because there's only a 10% chance that, given that this is true, that the sample mean would fall into here. So this is called a left tail test, and we shade the left tail because the unlikely value sample means, or the unlikely sample statistics, would be less than k, so it would be over here. Conversely, if the null hypothesis says mu is less than or equal to k, then the alternative hypothesis would be mu is greater than k, and the unlikely sample means would be over here. So this would be our rejection region. We have a right tail test. And then in the case where our null hypothesis has equality in it, mu equals k, the alternative of that would be mu is not equal to k. So it could be that unlikely means could be both less than k and greater than k. So these are the two extremes. We need to do a two-tailed test in which the combined regions here is equal to alpha, which is the level of significance. So what we're doing is these are rejection regions. If our standardized test statistic falls into these regions, then we reject the null hypothesis. Okay, and if we're wrong, we know that the chance that we're wrong and the probability that we're wrong is exactly alpha. Okay, just to go some really quick examples. Let's say if a manufacturer claims that the mean life of a battery for a tablet is more than 8 hours, well, the claim as a statement, you would write that is mu is greater than 8. Okay. Now, because this has strict inequality, this can't be the null hypothesis. In fact, this has to be the alternative hypothesis. And the null hypothesis would be the opposite of that. It would say mu is less than or equal to 8. Okay. Now, this was our claim. So the way we would play this game is that we would assume that this is true. We would assume that mu is less than or equal to 8. Then the alternative hypothesis that mu is greater than 8. We would use a right-tailed test in this case. And then depending on whether our statistic is in this region or not, we would either be able to support the claim or not support the claim. Okay, depending if our statistic falls in this region, we reject the null hypothesis and we support the claim. A couple more examples. If a campus security department says that at most 25% of applicants become security officers, this is a statement about proportions. So the claim is saying at most, so P is less than or equal to 0.25. That's our claim. And since this has equality in it, this must be the null hypothesis. And the alternative hypothesis would be P is strictly greater than 0.25. Okay. So when we evaluate this claim, we're either going to be rejecting it, or we're going to say there's not enough evidence to reject it. We can't really out and out say we support this claim. Okay. And again, because if this were true, the unlikely values of P would be greater than 0.25. So once again, we have a right-tailed test. Okay. In this last example, an urban planner claims that the noontime mean traffic flow rate at a certain street is 35 cars per minute. Is 35, that means the mean equals 35. Okay, so that's our claim. And because it has equality in it, this is the null hypothesis. The alternative hypothesis would be mu is not equal to 35. And in this case, we would have a two-tailed test. Okay, and once again, we would either reject the claim, or we would say there's not enough evidence to reject the claim. We can't really say there's enough evidence to support it or not support it because the claim is the null hypothesis.